The chemicals that we release into our atmosphere have a wide-ranging effect on the natural world. Rivers like this one in the Peak District can be devastated by contamination. Chris Curtis of University College London has been monitoring pollution and its effects on the countryside.
I'm just going to test the pH of this drinking water. This is good old London tap water. For comparison with acid river water sample. And as you can see, when I put the probe in the tap water, the pH goes up to about 7, which is circumneutral. So that's neutral tap water. But if I then put the probe in the stream, the pH value goes down to about 5.2. Now, because that's a difference of 2 pH units, but because pH is a logarithmic scale, that actually means it's not 10 times, it's 100 times more acid in the stream than it is in the tap water. So we're trying to collect the insects and other invertebrate animals that live under the rocks and in the gravel to see which species are present and see whether there are any acid-sensitive species present, which might indicate that this system is recovering from acidification. And what we can see is that there's actually not very much here. That might seem like a bad thing, but it does tell us a lot about the stream, and it tells us that the water quality isn't very good. In other words, it's very acid. If we went to a very healthy lowland stream with a high pH, we might expect to find a very diverse community of invertebrates living in the sediments and under the rocks in the stream. With the invertebrate thing, it tells us that they could have been killed by acid episodes in the stream.
Rob Mills from Bangor University uses a different technique to test acidity in the environment. He is trying to assess the impact of acid rain by isolating small plots of land away from the influence of people and cars. In this first section of test plots, the soil is open to the elements as normal. But in the second block, a plastic cover shields the plants when it rains. Instead of rainwater, these sheltered plants receive the same quantity of distilled water. However, not all the moisture in the soil comes from rainfall. Some of it comes from the dense fog that regularly covers this area. This water can also be tested using an ingenious collection.
Okay, what this is we call it the cloud collector. And essentially what it does is it collects clouds. So as the clouds move across the hillside, they come across this fishing line wire, and small droplets from the cloud condense on here, run down into the funnel, and we collect it at the bottom. And this is another way of us getting an idea on how much acid material is coming into the system. We can have a quick look at this. And what we can find in here is that this will be full of a range of particles. And these particles are what the water droplets condense around. So this could be particles of dust from car vehicle emissions, from fossil fuel power plant emissions. And each one of these tiny little specks of black dust could represent a single droplet. But of course, this material then eventually enters the ecosystem, and the consequences of which we're trying to find out.
Another of Rob's tests assesses the effects of global warming. He covers some plots at night in order to raise their temperature. Over several years, Rob wants to see how the effect of temperature alone affects the plant's growth.
Global warming is a product of a natural phenomenon. So naturally we have the greenhouse gases which exist in the atmosphere, which allow life on Earth to exist. But global warming is a function of what we term anthropogenic activities. That's all of human activity. And over the past few hundred years, we've been contributing a lot more of these greenhouse gases to the atmosphere. Essentially what we're seeing is the climate is changing, not necessarily always getting warmer everywhere, but generally speaking the climate is changing, and we can term that global warming or global climate change.